Okay, so question number 2 on, let's see, what page is this? Page 100 out of the textbook is like what people have been asking me. And they're asking me, I've got, it's just on the standard normal curve, so I know that's because I'm talking about z-scores. And they've asked me some questions about, it's not a lot of mathematics, algebra per se, but there's some thinking here. So they're telling me, hey, I've got some z-score. I've got some z-score that has a probability of less than that at 0.85. Why is the probability of more than that z-score 0.15? Well, under the area of the curve, under the curve is 100% or a probability of 1. If I've got 85% to the left, that means I'm going to have 15%. Whoops, no, sorry. If there's 85% to the left, that means there's 15% to the right, or 0.15, for if you want to talk about a probability, because 1 minus 0.85, right? So that's the question A, and that's why. I guess did I answer the give 2 reasons why the probability of that is greater than 0.15. What's the probability? There's 2 reasons. Well, I know the area has to be 1. I know the area to the left is 0.85. The area above has to be 0.15. So that's 1 reason. What's another reason? I don't know. Can't think of that this morning. Well, complements. Maybe I'm using 2 at once. I don't know. All right. How do I know that the z-score has to be positive? Well, I know the z-score of 0 cuts off the middle of 50%, because in a symmetric distribution, the mean and median are the same, right? Normal distributions are symmetric. So that's why it's, and so in a z-score will have to be positive to be more than 50%, right? And that's pretty straightforward. So now the question C is what's been giving people a hard time out of WebAssign. So I'm out at David Lane, that David Lane applet that I've been telling you about, and I selected value from an area. I don't want to do area from a value because I have the area. I have that the area is 0.85 to the left. I want to know, so basically what I got to do is I got to find the z-score that cuts off that bottom 85%. And mean of 0, standard deviation of 1, because I'm on the standard normal curve. So the applet tells me that z-score is just a little bit bigger than 1.036. So that's that area. So now, I mean, that's that z-score that cuts off the bottom 85% or the upper 15%, if you want to think about it that way. So now they're telling me, what if you take that z-score and make it negative? And they're asking, what's the area between the negative of that and the positive of that? So I'm going to go back to area from value, because now I'm looking for an area. Now I want to know between that negative z-score and that positive z-score. And that's what they're telling me the area is. Now, why does that work? Why is that almost 70%? Well, if this upper tail is, remember back here when we were doing the 85%, the 0.85, that's 15%, because 100 minus 15. Now we're going to put that same tail off to the left. Or did I lose it? Here we go. Recalculate. There we go. If that's 15% here, I think I can get a pointer going rather than just using my mouse. Because this is 15%, this tail is also 15% because they're symmetric. 15 plus 15 is 30, 100 minus 30 is 70. That area is about 70%, 0.175 or 0.70. And of course, if you round that to 2 decimal places or even 3 decimal places, that's what you're going to get. But he's really there. I think what Dr. Stevens is trying to get you to think at, well, if that's 15, that's 15, that's 30, find the complement. Okay, so that's what that's asking you to do.